appears to be working. It is working. Wonderful. Cool. I suppose we will start just doing some math. Let's see. So one of the common problems that I end up seeing a lot as I'm tutoring is fractions. So we'll start with that. If I'm adding fractions, I have a over b plus c over d, and I want to find out what goes in the blank. Well, if I add a half and a fourth, we want to find what that number is, so we have to get a common denominator. We have a 4 over here, and I can turn a 2 into 4 pretty easy, but I can't turn 4 into a 2. So we're going to multiply by 2 on top and bottom, which will give me 2 over 4 plus 1 over 4 equals 3 over 4. So that's 3/4. And the reason this works is because 2 divided by 2 is just 1. So what we're really saying is 1 times 1/2 plus 1/4 is the same as saying 1/2 plus 1/4 is equal to 3/4. So we're using this step as an intermediate to make it easier to get to there. So if we want to do that in a more general case up here, we're going to say a over b plus c over d is equal to a times d over b times d. And now that works, but we don't have a b over here on the bottom. So we now have a common denominator on this side, but not on the other. So we're going to multiply by b on that one. Not a. C times b over b times d, which is equal to, now these are the same, so we can add the tops. So we have a times d plus c times b over b times d, which is what we have down here. So we plug in our numbers. We'll say, instead of a over b, we'll come back and check this. A over b is going to be 1 over 2. C over d is going to be 1 over 4. And then we'll test this formula. So we'll do a, which is 1, color code it. We have a and a. We have a little bit smaller. We have b and b. We've got c and c. We've got d and d. So now anywhere I have the green, we'll plug in 1. Anywhere we have red, we'll plug in C, which is 1. Anywhere we have the yellow, we'll plug in 4. Anywhere we have this orangey brown, we will plug in 2. So we'll do 1, times 1 plus 1 times b is 2 divided by 2 times, and then we have in the yellow, we have 4. That's a 4. Which is going to give us 1 times 4 is 4, plus 1 times 2 is 2, plus 2 over 2 times 4 is 8, which gives us 6 divided by 8. Now you're saying, wait a minute, that's not the same number, but hang on. We know that 2 times 3 is 6, and 2 times 4 is 8. So when we pull out the 2's, we can cancel them out because that's the same as saying 2 over 2 is equal to 1, which is 1 times 3 over 4, which is equal to 3/4. So they are the same. Let's see, what else can we do? Let's do some linear equations, because those are always fun. So I have an equation in the form a times x plus b times y equals c. For example, I have 3x plus 2y equals 6. I want to know what is the graph of this function. Well, the first thing that I'm going to do is I'm going to get it into a standard form that I recognize, which is y equals mx plus b. Okay. Which means we've got to rearrange this equation using some algebra. So what we're going to do is we're going to say, all right, I start with this, but I want to get the y by itself, which means I'm going to do b times y. We'll step back a little bit. If I'm starting with ax plus by equals c, my next step is going to be to get the y by itself, and in order to do that, I have to subtract this ax off. And we know we have to subtract because there's an imaginary plus at the front. So to get rid of the plus ax, we have to add minus ax. So ax plus by minus ax equals, and then we have to do the same thing to both sides. So if we subtract on one side, we gotta subtract it on the other. Now this and this cancel, so we'll get rid of it. And we'll say by equals c minus ax. Now I still want to get the y by itself, but I got a b in the way. So what we're going to do is we're going to divide by b. Since it's b times y, if we want to undo the multiply, we divide. So we're going to do 1 divided by b times that side, and move this, divided by b on this side, gives me a 1 divided by b over here. Those will cancel, like so, and I'm left with a y. So when I do this, I have a 1 times y equals 1 divided by b times c minus a times x. Now I have y equals, and I'm going to put all of this on top of the fraction because I like it a little bit better that way for now. C minus a times x divided by b. But now that's not a proper fraction. So we're going to do c, actually I think it is, but I don't like it as much. C over b minus a over b times x. And I can move the x off the top because it's all multiplication. And this is now the correct form to match this. So now my m is equal to negative a divided by b. And my b is getting kind of abusing the notation a little bit, but this b is equal to this. Let's actually change it because it's bothering me. We'll say this is a c. No, we won't. We'll say it's smiley face. Smiley face is equal to c over b. And now we want to know what the graph looks like. This one. So to do that, we're going to say, where's my ruler? I should have a ruler here somewhere. Maybe it's not there. Over here? Nope. It's right here. Start there. Let's draw ourselves an axis. We'll call that 1, 2, 3, 4, 5, -1, -2, -3, 4, -5. What was that? 5. 1, 2, 3, 4, 5, 6, 7, and so on. And this goes off that way, that way, that way, that way. So now we're going to come back up here, and we're going to take this, which is going to be, according to our formula, it's going to be y equals 6 divided by 2 minus 3 divided by 2 x. This is going to simplify to be 3 divided by 1, which leaves us y equals negative 3 halves x plus 3. So now we can take that formula, which I'm going to copy and paste so that we can see it. Duplicate. We're going to start at positive 3, because when we plug in 0 for x, y equals negative 3 over 2 times 0 equals, this all goes to 0, and and that becomes just plain old 3. So then we have the point y equal to 3 when x is equal to 0, which gives us the point 0, 3, because that's x and y. Now we'll plug in another point. So if we say x equals 1, we'll start a table as well. X, y. We plug in 0, we get 3. We plug in 1, we get y equals negative 3 over 2 times 1 plus 3 equals negative 3 over 2 plus 3. Now we got to do our mixed fraction thing, but this is actually a 3 over 1. So we're going to do negative 3 over 2 plus 3 over 1 equals negative 3 over 2 plus 6 over 2 equals 3 over 2. So this is 3 halves, which is 1 1/2. So we're going to go up to 1 and about a half. And that'll be our point there. We'll go to negative 1 and see what happens. So if we have x equal to negative 1, then we have negative 3 over 2 times negative 1 plus 3. And the negative and the negative cancel, and we're left with a positive. And we got to do more mixed fraction stuff. So 3 over 2 plus 6 over 2 equals 9 over 2, which is 4 1/2. That is not what I wanted to do. This one. So now we'll put a dot at 4 1/2 and negative 1. So that's going to be right about there. Now, we can sketch our line through here, but there's another easy way if you have a graph. We can take our line tool, or a ruler for you guys, and we're going to say this negative 3 over 2 is going to tell us our slope, and we know where the center point is. So we're going to go from the center point, we're going to go, it's rise over run, so we're going to go down 3 and over 2. Down 3 and over 2. Down 3 and over 2. And to go backwards, we'll just go over 2 and up 3. Over 2 and up 3. And that's our line. So that is one way to plot the line. What if we're dealing with polynomials? Got y equals some 2x squared plus 3x minus 1 what's the graph of this one look like? One of the first things that we're going to want to do is find the roots. So where does it cross the x-axis? So if you know what a normal polynomial looks like, or normal quadratic, I should say, it's going to look something like this. And we want to know, where does that point happen? Where do those points? These are called our roots, or zeros. Roots. Zeros. There's another important point called the vertex. And this whole shape is called the parabola. And we say the general form is y equals ax squared plus bx plus c. And you've probably heard of the quadratic formula, which is if we have this and we want to know where the zeros are, we'll use the formula x equals negative b plus or minus the square root of, b squared minus 4ac all over 2a. So in our formula, we're going to say the roots are negative b, so b is the number with the x all by itself, so we'll have positive 3 that's negated, plus or minus the square root of b squared, so 3 squared minus 4 times a is 2, c is negative 1, all over 2a, which is 2. So that's going to give us negative 3 plus or minus the square root of 9, plus, we have a negative here and a negative here, so we're going to combine them and will give us a plus. 4 times 2 is 8. Divided by 2 times 2 is 4. Now, you have negative 3 plus or minus the square root of 9 plus 8 is 17, divided by 4. Now, I didn't pick these numbers carefully when I constructed the problem, so we don't have nice pretty numbers for our graph. But what we're going to do is we're going to say we have negative 3 over 4 plus or minus the square root of 17 over 4. Now, if I was going to do this without using a calculator, I would say 17 is close to 16, and the square root of 16 is 4. So this number is a little bit bigger than 4. No, it's not. It's a little bit bigger than 1, because the square root of 17 is going to be bigger than the square root of 16, which is equal to 4. And since we have a number a little bit bigger than 4 over 4 itself, we know this number is going to be a little bit bigger than 1. So going with that for the time being, we'll do negative 3/4 plus or minus 1. So we have we got negative 3/4 plus 1 and negative 3/4 minus 1. Put the little tilde there because it's approximate. So it's going to be about negative 3/4 minus 1, and another one at about negative 3/4 plus 1. Negative 3/4 plus 1 is just positive 1/4, right? From our adding fractions earlier. This is going to be negative 3/4 plus 1 times 4 over 1 times 4 equals negative 3 plus 4 over 4, which is 1 over 4. And this one is negative 3/4 minus 4/4 is equal to negative 7 over 4. So for our picture, we're going to draw it, or we're going to start drawing it. Where we have a point at 0 on the vertical axis, which means somewhere on that line. At x equal to 1/4. So if we say this is 1/4, this is x, this is y, that's 1 over 4. And so since that's 1 square, we got to go 7 squares on the other side. So this is 1/4, 2/4 or a half, 3/4, 4/4, 5/4, which is 1 1/4, 6/4, 7/4. So we want it right here. Negative 7 over 4. Now we know from other stuff about parabolas that this vertex, this peak point, for the case of a second degree polynomial where the highest term is a 2, that point happens exactly halfway between the zeros. So what we can do is we can say x vertex equals 1/4 plus negative 7 negative 7/4 divided by 2, because that's the average. Now this is already where the fourths, or where they're both in terms of fourths, so it's a common denominator already. So we have 1 plus negative 7 is going to be negative 6 over 4 all over 2. Now when we have a stacked fraction like this, I like to make this the biggest fraction, the one with the fractions on top. I like to make this bar bigger so that it's obvious. So what that means is we have 1/2 of negative 6/4. Now we got two things we can look at here. We can either combine the fractions and then simplify, or we can simplify this one and then combine them. What I'm going to do is I'm going to say 2 and 6 they share a factor, namely 2, so that's going to become a 1. This is going to become a 3, and we're going to end up with negative 3 over 4. So the vertex of the parabola happens at negative 3/4. So we go negative 1, 2, 3/4. So somewhere on this on that line is the vertex. But since we have the formula right here that we started with, we can find out where the vertex is. So if we go y equals 2 times, and this is negative 3 over 4 squared, plus 3 times negative 3 over 4 minus 1 is equal to 2 times negative 3 squared is 9, 4 squared is 16, plus 3 times negative 3 is negative 9, over 4, minus 1, and then we multiply the 2 in, so 2 times 1/16 is 1/8, so 1, and that's an 8, so that gives us 9/8, plus negative 9 over 4, minus 1. Now we can turn all of these into eighths really easy. So we're going to do 9/8 plus, that's times 2, that's times 2, that's times 8 over 8. So 9 plus negative 18 over 8 minus 8 over 8. And now we're going to do, we're going to combine everything so it's all over the same bottom. So negative 18 minus 8 is going to be negative 26. 9 minus 26 is going to be 15, negative 15 over 8, which is going to be a little less than 2, so it's going to be 1.875. I believe that's correct. So now we'll check the numbers. Calculator. That's not a calculator, that's a calculation. Where's my calculator? Applications. Calculator. So we're going to do 1.87. Nope, we're not. We're going to do 15 divided by 8. 1.875. So that's correct, based on our assumption that the roots are sufficiently close to their rational counterparts. So now we're going to do, just check to see how close is this rational counterpart. So we're going to do 17. Where's the square root button? Nope. Is there not a square root function on this calculator? Am I missing it? There is not. All right. (17) square root divided by 4. 1.03, which I think is close enough for our purposes. So 1.875 is going to be, that's negative, 1.875 is going to be almost to negative 2, but not quite. So we'll say this is negative half, negative 1, negative 3/2, negative 2, which means we'll be, that's halfway, so that's negative 1 3/4, and we're halfway between that. So that's the vertex, which means our parabola, if I can draw it correctly, is going to look something like that. Now, if I bring up Wolfram Alpha, which I think that's not the right button, this one. And I ask it, what is the graph of our formula? Y equals 2x squared plus 3x minus 1 It doesn't work. No. Hang on a minute. Squared plus 3x minus 1. Can I add a snippet? Something else? I think this works. Can I paste it in? Oh, graph me. That'll work. 2x squared plus 3x minus 1. And you're not working because 2 times x. There we go. And we'll set our display to be the same as my graph, which goes -2 to +2, -3 to +3. Okay. And that's pretty much what our graph looks like. Albeit theirs is prettier. So this number, according to the displayed graph, is 0.28, which is pretty close to our 1/4. This one is -1.78, which is pretty close to our -7/4. And the peak right here in the middle looks like it happens around -3/4, which is exactly what ours was. Right there. So that is how you do a polynomial. Given my viewership, I think we're going to call this good for now. If you have any other questions, leave them in the comments below. And we'll catch you next time.